Welcome to Trust Access, your identity expert podcast.
Great to be here.
Today, we're doing a deep dive into something super practical, the ultimate PlainID caching cheat sheet, basically your guide to turbocharging your authorization engine.
Yeah, this is a big one. We hear about this a lot, and honestly, it's understandable. So many folks run into that frustration. Authorization looks great on paper, then hits production under heavy load, and suddenly
Things slow down.
Yeah,
That promise of seamless security kind of hits a performance wall sometimes.
exactly.
So that's our mission today. We want to really unpack this cheat sheet, pull out the most important nuggets, give you actionable insights you can actually use to boost that performance.
And just to be clear up front, we're really zooming in on the application level caching within PlainID, the stuff you can directly control.
Right.
We're not getting into the weeds of the underlying PlainID store policy caches today.
Yeah.
They're important, no doubt.
Yep.
But today's focus is on those levers you can pull for, well, more immediate impact.
Got it. Okay, let's start unpacking. First up, the policy decision cache. The cheat sheet calls it our first line of defense.
It's a good way to put it. Think about it like this. It stops your system having to answer the exact same question over and over again, like a toddler constantly asking why.
Okay, I get that analogy.
It tackles that core problem, recalculating identical requests from scratch every single time. Imagine your whole marketing team hitting the same dashboard, maybe multiple times a day.
Right. Without caching, that's just...
It's a whole recalculation
Yes.
every single time. Policies evaluated, attributes fetched. It's wasteful.
Sounds incredibly inefficient, like constantly reinventing the wheel.
Precisely. But turn on the policy decision cache, and PlainID gets smarter. It basically goes, hang on, seen this before? Same user, same resource, same action. I know the answer.
And boom.
Instant response.
Pretty much for those identical scenarios, yeah.
Okay, so how does that work technically? Where's the magic happening? It's actually quite clever. The cache stores that specific yes or no decision right next to the PDP. That's the policy decision point, the engine doing the evaluation.
Okay.
It stores it in the Redis store. So when the exact same request comes in again, PlainID just grabs the stored decision. No need to reevaluate everything.
The benefit seems crystal clear then. Lightning fast responses for common stuff. The cheat sheet had a pretty compelling example, didn't it?
It did, yeah, and it really drives the point home. They mentioned a client whose response times for common scenarios went from like 200 milliseconds, which can feel a bit sluggish,
Yeah.
down to under 10 milliseconds.
Wow. That's a 20x improvement.
20 times? Think
Wow.
about how much snappier that application feels to the end user. That's the key takeaway here. For those repetitive requests, this cache can make things feel almost instantaneous. It really changes the experience.
Okay, a 20x improvement is definitely not something to ignore. So how do we actually set this up? Where are the knobs and dials for this policy decision cache?
It's pretty straightforward in the PlainID management console. You'll find it under Environment Settings, then Scopes, and there's a cache duration setting there.
Under scope, so it's per application, basically.
Exactly. It's scope dependent, which gives you nice flexibility, right? You can decide which apps really need this and which maybe don't have as many repetitive requests.
That makes a lot of sense. Not all apps are built the same.
For sure. And the cheat sheet mentioned something else that's pretty useful too. Even if you enable caching for an app,
Yeah.
the application itself can actually tell the PDP, hey, for this specific request, ignore the cache. I need a fresh decision right now.
Oh, okay. So you have an escape hatch if needed. That's good flexibility.
Definitely valuable, yeah.
All right, that's a solid first step. Let's move to the second line of defense, the identity source cache. The cheat sheet really flags this one as crucial, especially if your identity provider, your IDP, isn't exactly speedy.
That's right. Think about all the times PlainID needs user info department, role, group memberships, you name it, to make a decision.
All the time, basically.
Pretty much.
Yeah.
And without caching, every single time PlainID needs, say, your department, it has to go ask the IDP. Or maybe some other attribute source, like an HR system.
That sounds like it could add up really fast, like calling your mom for that recipe every single time instead of just writing it down once.
Huh. That's a perfect analogy.
Yeah.
The identity source cache is like writing down the recipe. PlainID fetches the attributes once, stores them for a period you define, and then just looks them up locally.
So it takes a load off the IDP.
Exactly. Reduces load on the IDP, reduces load on any other attribute sources that might be slow or maybe even external. Maybe your IDP is in a different data center, network latency is a factor, or an API is just slow. This helps smooth all that out.
And the big win, again, is performance. Fewer external calls equals faster decisions.
Absolutely. Big time.
So where do we configure this one?
For this, you'll go into the Identity Workspace settings, then look for attribute sources. There's a cache duration setting there too. But here's the interesting thing. The default is actually 0 seconds, meaning caching is off by default.
Wait, really? Off by default? That seems counterintuitive given the benefits. Why?
That's a fair question. Often the thinking is safety first, right? Defaulting to off ensures you're always getting the absolute freshest identity data. Maybe there are strict compliance rules or attributes change super rapidly in some places.
Okay, I can see that logic. Freshness versus speed.
Exactly. But for a lot of situations, the performance gain you get from even a short cache duration, maybe a few minutes, far outweighs the tiny risk of data being slightly stale, especially for attributes that don't change that often.
And the cheat sheet had a good tip on that, right? About different attributes.
Yeah, a really practical pro tip. It basically says, hey, not all attributes are the same. Someone's department probably doesn't change every 5 minutes.
Hopefully not.
Right, so maybe you cache that for longer. But group memberships, those might change more often as people move between projects or roles.
So shorter cache time for those, or maybe none at all.
Exactly. And the cool thing is, PlainID lets you get that granular. You can tune the cache duration at the individual attribute source level, right within the identity template.
Okay, that level of fine-tuning sounds really powerful. All right, we've covered decisions and identity attributes. Now we get to what the cheat sheet calls real magic happens. The policy information point cache, the PIP cache.
Yes, the PIP cache. This one is absolutely vital when your authorization decisions depend on more than just who the user is. We're talking about data, about the things they're trying to access, or other contextual info.
Like what specifically?
Oh, things like specific feature entitlements a user has, maybe an account status pulled from a CRM, or even a risk score coming from a fraud system, data that lives outside the core identity provider.
Okay, and without this cache, I'm guessing every single permission check needing that data means hitting those external systems.
You got it. Every single time.
Yeah.
And if those external systems, your CRM, your billing system, whatever, are slow, or they're getting hammered with traffic,
Your authorization performance just tanks.
absolutely. It becomes a massive bottleneck. Imagine trying to authorize a financial transaction, but having to wait for a response from an overloaded back-end system every time. Not good.
Definitely a performance nightmare waiting to happen. So how does the PIP cache save the day?
It essentially keeps a local copy of that external data right there within PlainID. And this copy gets refreshed periodically at intervals you control.
Okay, a local snapshot.
Exactly. And what's really neat is that this cache isn't always just raw data from one source. Often it's based on a view you define in the PIP, which can actually combine or transform data from multiple backend systems before caching it.
Ah, interesting. Now, the cheat sheet mentioned two different flavors of PIP cache, persistent and in-memory.
That's right. Two main types. You've got the persistent cache. This one stores the data in a dedicated database.
Okay, so it survives restarts.
Precisely. That's the big advantage. If a PlainID service restarts, the cache is still there, ready to go. It ensures consistent performance even after maintenance or, unexpected hiccups.
And the other one, in-memory.
In-memory cache keeps everything right in the server's RAM. The big benefit, speed. It's incredibly fast, like lightning fast access.
Sounds good. What's the catch?
Well, it uses more memory, obviously, and if the service restarts, the cache is gone and needs to be rebuilt. It's ideal for really high throughput scenarios where every millisecond counts, and you have the memory resources to spare.
So how do you choose? When does speed trump memory usage or persistence?
That's a great question. It often boils down to a few things. How critical is absolute minimum latency for this application? Do you have the available RAM? If you're pushing millions of transactions and have beefy servers, in-memory might be the way to go.
But if memory is tighter or a slightly longer response sometimes is okay.
Then persistent cache is probably a safer, more resource-friendly bet. Also, think about how often the underlying data changes. If it's changing constantly, maybe in-memory's faster refresh is beneficial. It's a trade-off.
Okay. The real-world example for the PIP cache in the cheat sheet was pretty dramatic, too.
Yeah, it really was. An enterprise client pulling data from a sometimes sluggish SAP system.
Right.
They were seeing authorization times up to 2 seconds sometimes, which is an eternity in application time.
Ouch.
By implementing PIP caching, refreshing the key SAP data every 15 minutes, they got those decision times down under 50 milliseconds.
Wow. From 2 seconds to under 50 milliseconds. That's huge.
Massive difference in user experience and system stability. So yeah, the key takeaway for PIP cache, it's your buffer. It insulates you from the unpredictable performance of those external systems. Gives you consistent speed.
Okay, that makes total sense. Now, what about those situations with just enormous amounts of data? The cheat sheet introduces lazy caching for that. Sounds intriguing.
It is a really interesting approach, yeah. Think about a huge e-commerce site. Millions of products, right?
Yeah.
And maybe authorization depends on some specific attribute of product.
Trying to pre-cache all of that product data up front sounds impossible, or at least really resource heavy.
Exactly. Impractical. So lazy caching flips the script.
Now, so what's the lazy part?
It takes a just-in-time approach. Instead of trying to load everything proactively, it only caches a piece of data the first time it's actually needed for an authorization decision.
Ah, okay. So it only bothers fetching and storing it when someone actually asks for it.
Precisely. Then, if the same piece of data is needed again soon after, boom, it's served from the cache. It's like only getting a specific reference book off the library shelf when someone actually requests it, instead of trying to photocopy the entire library beforehand.
Much more efficient for those massive data sets. How does it decide what stays in the cache? Does it fill up eventually?
Good question. While the cheat sheet doesn't explicitly mention a configurable TTL for lazy entries, it does point out the underlying mechanism usually uses an LRU policy, least recently used.
LRU, so the stuff that gets accessed most often sticks around.
Exactly. Data that hasn't been touched in a while gets kicked out automatically to make space for newer, more relevant data. Keeps the cache focused on what's actively being used.
Makes sense. How do you configure this? Sounds like it might be a bit more technical.
It's a bit more under the hood, yeah. You configure lazy caching via the config map for the PlainID runtime. Specifically, in the plainid-runtime-config.yaml file.
Okay.
You essentially add some specific parameters to the connection URL for the PIP data source you want to enable it for. The cheat sheet gives a clear example for a JDBC connection, showing the kind of parameters you'd append. It's definitely something you coordinate with your PlainID administrators or DevOps team.
Right, not just a checkbox in the UI. The use case they gave was pretty compelling, too, a big financial institution.
Yeah, global finance, millions of financial products. They realized pre-caching all the details needed for transaction approvals just wasn't going to fly.
Too much data.
Way too much. So they implemented lazy caching, and they found it ended up covering something like 80% of their requests just by caching the most frequently accessed product data on demand.
That's pretty impressive coverage.
It is. Now, the cheat sheet is honest. It does acknowledge you might get a slight delay on that very first access for a piece of data that's not in the cache yet, the cache miss.
Right, the first person asking for that obscure product might wait a fraction longer.
Exactly. But overall, for the vast majority of requests hitting the cache data, the performance gain was huge, and it massively reduced the resources needed compared to trying to pre-cache everything.
So it's a smart trade-off for those really large-scale scenarios, optimized for the common case?
Precisely. It's about finding the right strategy for the scale of your data.
Okay. Now, the cheat sheet also quickly mentions a couple of other more specialized caches, JWKS, cache, and secrets cache.
Yeah, these are kind of important background players. First, the JWKS cache. JWKS stands for JSON Web Key Set.
Right, the keys for verifying JWTs.
Exactly. This cache just keeps those public keys in memory. Why? To speed up the validation of API calls that come in using JWTs for authentication or authorization, makes that check much faster.
And where is that configured?
This one's typically in the values-custom.yaml file, part of Helm deployment usually. There's a refresh JWKS parameter. But, honestly, the cheat sheet suggests, and I agree, the defaults are usually fine for most people unless you have absolutely massive API volume or maybe some instability with your key provider.
Okay, so mostly leave it alone unless you have a specific reason. What about the secrets cache?
Right. The secrets cache is all about optimizing how PlainID signs the JWTs it might issue as part of a response.
Okay.
It reduces how often the PDP needs to go talk to your secret manager, like HashiCorp Vault or Azure Key Vault, to grab the private keys needed for signing.
Makes sense. Fewer calls to the secret manager.
Exactly. And the really nice thing about this one is that it's pretty much self-managing. The PDP keeps an eye on the certificates, checks for changes about once a minute, and refreshes its internal cache automatically if needed.
So generally, no knobs to twiddle for this one.
Generally, no. It just works quietly in the background, making things more efficient.
Got it. So those two are important supporting players handling specific crypto tasks efficiently.
Exactly right. Critical pieces, but less direct tuning usually needed compared to the main data caches.
Okay, we've walked through all the individual cache types. Now, maybe the most important part. The cheat sheet wraps up by talking about how to bring it all together. Crafting your caching symphony, they call it.
Yeah, this is crucial because just knowing about the caches isn't enough. You need a strategy for how and when to apply them effectively. It's about building a cohesive approach.
So they provide a kind of step-by-step framework.
They do, yeah. A very practical sequence to think about.
Let's walk through it. Step 1. Enable the identity source cache first.
That's the recommendation. Start by taking the pressure off your IDP and any other identity sources. Get those basic user attributes cached.
But there's a caveat, right? Talk to the identity overlords.
Huh. Yes. Crucial point. Before you just flip the switch, you absolutely need to talk to the team managing your identity systems. Understand their requirements. How quickly do authorization decisions need to reflect identity changes? Is a 5-minute delay okay? Or does it need to be instant?
It's that balance again. Performance versus freshness.
Always. You need to agree on what's acceptable for your specific context.
Okay, step 1. Identity source cache with coordination. Step 2. Layer in the PIP cachings.
Right. Once you've tackled the core identity attributes, then focus on caching that external data from systems like CRMs, databases, APIs, etc., using the PIP cache.
And same principle applies. Talk to the data owners.
Absolutely. You need to understand how often that data changes, and again, how much potential staleness is acceptable for your authorization rules. Coordinate those cache refresh intervals with the people who own the source data.
Makes sense. Step 3. Unleash the policy decision cache.
Yeah, this one comes third in their sequence, partly because it's so application-specific. Unlike the identity and PIP caches, which might be more foundational, the decision cache is tuned app by app via scopes.
Right.
So here, you look at each application. How many identical requests does it typically see? What's the actual business impact if, for a brief period defined by the cache duration, a decision is based on slightly old data? Because maybe an underlying attribute cached by PIP or identity cache hasn't refreshed yet.
So it's a very granular evaluation for this one.
Very much so. It offers quick wins, but you need to be thoughtful about that trade-off per application.
Okay. Then step 4 is lazy caching.
Right, and that's positioned as the specialized tool. Only bring this in when you hit those scenarios with truly massive data sets where pre-caching with PIP cache just isn't practical.
Your e-commerce site with millions of products, or the finance institution example.
Exactly. It's for those specific large-scale challenges.
And the final step. Sounds like it's never really done.
Definitely not. Step 5 is continuous monitoring, measuring, and tuning. Caching isn't set it and forget it.
You need to watch it.
Constantly. Look at your cache hit rates. Are they what you expected? Or you see the performance improvements you aimed for? Are response times consistent? Based on that real-world data, you adjust. Maybe shorten the cache duration here, lengthen one there.
Always tweaking that balance between speed and freshness based on actual usage.
That's the key. Too short a cache time, you don't get much benefit. Too long, and you risk decisions based on stale data. You have to find the sweet spot, and that might change over time as applications evolve.
So, wrapping it all up, the core message seems pretty clear. Getting your caching strategy right in PlainID is absolutely fundamental. It's not just a nice to have, it's essential for building authorization systems that are both resilient and high-performing.
Couldn't agree more. It's what stops authorization becoming that bottleneck everyone dreads, the thing that slows down the whole application.
And ultimately, it impacts the user experience, right? A well-cached system means snappy, responsive applications.
Exactly. Users feel it directly when things are fast and smooth. Poor caching performance leads to frustration.
Well, this has been a fantastic deep dive, really clarifying how all these caching layers work together. Thanks so much for breaking down the cheat sheet and sharing all that practical insight.
My pleasure. It's a topic that comes up again and again, so hopefully this helps folks navigate it.
I'm sure it will. For everyone listening, if you want to dig into even more detail, check out the full article on our website or just follow the link in the description.